you guys doing today? All good? So a little bit of history. 1 year ago, I was here at the Texas Bitcoin Conference doing a hackathon. And I came with this little idea called storage. I said, well, what if everyone could sell their extra hard drive space to other users? That'd be kind of cool. So I went to the hackathon, coded it up a little bit, got some team members, and ended up winning first prize unanimously. So Texas Bitcoin Conference was my start, and I'm here returning to tell a little bit more about our progress and what we've been doing. So doesn't look like the video is going to work, so I guess can we just skip to the slide deck? That would be great. All right. So I'm going to go over the slide deck real quick, and then I want to get into questions. So storage is the project. And Storage Labs is the company that we're building on top of that. So all the project stuff should be open source like Bitcoin. And the company on top of that is about putting that out to enterprises and other companies to use. So we abstract all the crypto and blockchain mumbo jumbo stuff and make it easier for them to use. So next slide. So the basic pitch is that storage is Airbnb for cloud storage. You can have your hard drive, it has some extra space, you're not using it, why not sell it to other users, other people? And by doing that, you make it a lot cheaper because you don't have to maintain a giant rack of servers like all these other data centers have to, and you're having this resource that you're really not using that you can monetize. So consumers, you spend billions of dollars on computers that you barely use. But on the business side, they maintain these massive, giant data centers that use tons of energy and electricity and have many, many people running and operating and maintaining these. And so 70% of those data center costs are just maintaining it and the infrastructure. Well, the actual raw storage space is just about 7% of that cost. So we can eliminate 70% of these costs by just letting the users sell their extra hard drive space. You're already maintaining it, you're already turning it on, you're already powering it, you're already providing internet and electricity, all that to the computer. So why not just use that instead of having this massive data center? So in the US, we shipped about 66 million computers. And if you were to get that worth, if you were using 20% of that accessible storage, it would be worth about $1.4 billion. That's a lot of money. And that would go to you, the user, rather than some. Is that me? I don't know what that was. Maybe Amazon or Google was mad at my talk because I erased their business model. On the other side, you have a $15 billion cloud industry that's having a lot of trouble keeping track of security and privacy. So raise your hand if you know what happened to Sony in the last couple of months with all their data being hacked. You heard of that? That wasn't fun for them. All their data, all their communications were exposed. So this industry is having a very hard time with privacy and security. And that's one of the things that we can solve, and I'll get through that later in the talk. But it's a huge industry that we can eliminate, as in the previous slide, 70% of the cost. So that's huge. And Amazon and Google and all these other cloud providers are essentially in this knife fight with pricing. They're trying to bring down the pricing as low as they can get so they can get customers. But if we can eliminate 70% of the cost, well, they're in trouble. So we want to connect the crowd resources, you guys, with the business demand, the people who actually need this to store their data and their files, to create the largest and cheapest cloud available, and to cut out the cost of the data center. So brief overview of how it works. You have a user. They have access to their files. They encrypt their files with only keys that they know and have access to. Then they distribute these files out to multiple users. But we don't trust these users. We're distributed to Bob's or Alice's hard drive, so we don't know who they are. We don't trust them. So we audit them. We audit the files using mathematics. So we say, OK, do you have my file? I can verify mathematically that you have my file. It's still there. It hasn't been accessed or modified. Versus the previous way to do that is just to give it to Amazon or give it to Google and say, please hold my file, don't lose it, or don't get it hacked. So we're doing this through two applications. DriveShare is the application where users can sell their hard drive space. And on the other side of that, you have MetaDisk, which is kind of an encrypted Dropbox where you can drag and drop your files and encrypt it and send it to a DriveShare user. A little bit about our traction. We did a crowdfund not long ago after the hackathon and raised about $500,000 for the software and open source development. We had about 1,000 supporters in that. And we've started out our software with test group A. So we're trying everything on small scale. We want to build this out to a largest cloud storage network, but we got to start small first. So we're starting with 10 users, then 100 users, then 1,000 users. So this was test group A. We maxed out about 96 testers that helped test our early algorithms and see how they work. We have a pretty large community team. We consist of myself, a couple of developers, and a lot of community volunteers that are actually helping make this possible. I couldn't do this by myself. So just want to put some faces up there. And this is about it. We're essentially starting a little bit of a transition from the open source portion to the company portion. So we're building out the open source software. We've been building out the open source software. But really, we want to get into the hands of businesses. That's where the demand is going to be driven. We're going to say, hey, you're using cloud storage. We can do the exact same thing, more secure, cheaper, at half the cost. And so that's about getting this crypto technology into a business's hands, because that's a bit of a problem with Bitcoin, right? Why do you want Bitcoin? Why do you want to use it? You have all these advantages, but you have all these technical portions that make it difficult to use. If you can abstract all of that away, then you have some really powerful businesses. So you look at BitPay or Coinbase. Those are the companies that are getting a lot of the money in the space because they abstract it away. They make it very easy to use. So that's what we want to do for businesses, is take the software, all these benefits, and abstract away the technical portions so they can use it easier. All right, that's our website, contact information. So now I just want to open it up about questions, technical stuff, business model. Enough of the slides. Let's get into some real discussion in the time we have left.
Sean? Oh, hello. Thank you so much. Great presentation. Question about the basics of how it works. Let's say my stuff is encrypted. It's on Alice's hard drive. But then Alice is on vacation or computer's turned off when I need to access my files. How does storage work in terms of that?
So essentially, when you're distributing your files in this network, you want redundancy, right? If a computer goes offline or Alice's computer falls out of the window, you want to make sure that you can recover your data. So let's say you take your data, you encrypt it, you distribute it to 3 different people, and we're doing constant audits on these files. So if Alice goes online in the next audit, let's say every hour, we can detect that and say we need to put it on Bob's computer now, because we have 2 extra copies now.
Thank you, Sean. It's very impressive. Tell me, as a user, compared to the other competitors, if I were to give my hard drive out to the system, would I have enough revenue to pay for using the system to store my files elsewhere?
So yeah, so you're essentially going to get a token that you can either exchange for money or use to store your own files. So in that case, you could use the software, get some tokens, store your own files, and break even or gain a little bit of profit. So either or.
How do you avoid a sort of an industry takeover of this, kind of like what's happened with Bitcoin mining? You have a lot of, it's become an industry, and you've got very specialized hardware. It seems like Google or Amazon would be able to throw up, 1 billion terabytes, and just overwhelm all of the MacBooks that are sold, in an entire year. So how do you balance that and keep that?
So yeah, that's a problem in Bitcoin. You have this trend toward centralization, right? So you have this mining equipment, and you want to build the fastest chip so you can get all the Bitcoins, and that squeezes out the little guy. I used to be, in 2012, be able to get half a Bitcoin a day off my little GPU. That was nice. Can't do that anymore. So to fix that, we're building this on the market. So the idea is that you have a college student over here that's getting free electricity, free internet, all that kind of stuff. He can set his own price. So a data center or someone running this on a large-scale operation has to pay for those costs, where he doesn't. Those are sunk costs. So by letting the user set their own price, you can have a small farmer that can compete with a large data center because, again, his costs are sunk, his or her costs are sunk.
So I see you have over here. I see you have some international testers, and I'd imagine it is an international system, or that's the plan. How are you accounting for export control regs on the cryptography?
So that's a good question there. And something I might have to talk a little bit after and talk with the lawyers on that stuff. So there are some portions in terms of what happens if this goes to North Korea and they try to regulate it. So we don't want storage. I mean, at the end of the day, we're building an open source tool set, so it's just like Bitcoin. It can go anywhere, people download it. Yep. So we don't have any kind of control on what governments are going to try to do or trying to regulate this technology, just like they're doing with Bitcoin. But at the end of the day, it's an open source tool set. It can go anywhere. You can bring a flash drive or bring a computer.
Hey,
there you are. Okay.
Hey,
raise your hand so I can see you.
You mentioned earlier there's redundancy. What does that look like, and also how expensive is it? Is there a set amount of redundancy? Is it 5 times, 10 times, or is it?
So you or the application can set that redundancy. So by standard, you want like 3x redundancy distributed on 3 computers. But let's say it's your magnum opus, it's the most important file in the world, you might send a 500 times redundancy and distribute it all over the world. So that'll protect you against Armageddon and acts of God, pretty much. But you're going to pay more for that. So it's this per portion of data that you have on the system you're going to pay for.
2 questions. One, what's kind of your pricing approach for penetrating the enterprise market?
Say that again?
Your pricing approach for penetrating the enterprise market.
So we're going for, there's many different applications and many different pricing. So, Glacier is different from regular Amazon S3s. So we're pegging right now probably about half of the current pricing of major providers.
Hello, can you tell us how you use the blockchain, and I guess you have your own currency for distributing credits, or?
Yeah, so we're using the blockchain many, many different ways. This would not be possible without the blockchain. So one, we're using it for payments and rewards in terms of the cryptocurrency. The idea is that if you want to pay for space and you have $1, you can't use that dollar to pay 500 different people simultaneously and instantly. But you can do that with blockchain technology. The other portion is the audits. So the idea is that we're mathematically and cryptographically auditing these files, but we also need somewhere to timestamp and keep track of that. And so we're using the blockchain for that as well.
It seems like the latency of the data might be different than what I would get from the Amazon cloud, less predictable.
So in that sense, you can use gateway nodes. So the idea is that you can have a nice, fast server that you're routing your data through, in the case that you want latency, and then you can distribute it later. So in terms of latency, it's not so much a problem because you can use gateway nodes, or you can run the storage software in amongst a nice managed environment with low latency. But when you actually want to distribute the data, you can distribute it elsewhere.
What's your main, how are you going to compete with storage applications such as Google Drive that offer free storage?
So in terms of that, we're mostly focusing on the business side. So on the consumer side, there's offerings in terms of free storage. You know, Dropbox, Google Drive, they all give you free storage. Users don't like to pay for storage. They want it for free. So on the other side, we're looking more biomedical, academic, video production, people who are using large amounts of data and actually paying lots of money for it. Not by choice on their part. There's some pretty huge cost overages if you actually look at the raw storage numbers versus the services that these businesses are actually paying for. So that's why we think we're really going to burst into the market, because talking with people like the Baylor College of Medicine, they have 100 gigabyte cancer research files that they need to transfer around to different researchers, and they're using Amazon S3, and it's a huge bill. So if we can reduce that cost for them but provide them the exact same service, they're very happy to use it.
So if you have a set redundancy of, say, ×3 or ×5, and you pay for that, I presume, do you have any type of way to guarantee that there's nothing going wrong with those 3 computers simultaneously if you just only have
so
3
that's
times?
why we're doing the audit. So we're mathematically checking that those files are available and haven't been modified. And so if any one of those fails, then we say, that's not there anymore. We need to transfer one of our extra copies to another node or to another person. Other questions?
How do you see yourself in relation to IPFS and MadeSafe?
So in this sense, a lot of people peg us as competitors, and I really don't like that. In terms of decentralized technology, I know a lot of these guys, you know, had drinks with them, talk technical portions and ideas with them. So I see this more of as a heterogeneous network. So the idea is that in our front-end technologies, we can add in things like IPFS and MadeSafe and Filecoin and Siacoin. Because the idea is, if you have a heterogeneous network of multiple different ways of doing this, it lessens the attack vectors and increases the capabilities. So the users might download our MetaDisk application, store their file, but a third of it could go to MadeSafe, a third of it could go to storage, a third of it could go to Filecoin. So the idea is that you combine these technologies, you get something a lot better than just one. And they're all open source. The idea is that you have one technology or one API or another, you can build a wrapper to connect the two. So all these different projects are taking different technical approaches to the same problem. So I think it's better to combine them and work together than try to compete in the decentralized space. I won't name any names, but there have been some notable projects that have kind of thrown stones in glass houses, and it worked absolutely terrible for both. So I like these guys, I like talking to these guys, I like discussing some of the problems with them. We're really open to using IPFS at this point, which is essentially content addressable file system. So I see all these as just different approaches and should be considered if they're viable.
So is this like a completely free market system as far as the cost, and I guess maybe also people just speculating with the Factom coins?
So the idea is, yes, that it's a completely market-based or free market-based system. So the idea is that you have multiple different use cases. If I'm storing archival data, that's a lot less intensive than I'm using this for video distribution. And someone might care about where on their hard drive more than another person. So the idea is that the user that's storing the data and the user that needs that service of storing their pictures or their movies or whatnot should be able to negotiate that between the two of them. They should negotiate what that pricing should be and what those parameters should be in a contract. And then they can go from there. Because there's just so many different use cases, you can't fit storage into one little bucket.
Speculation aspect too, though, right?
I think less on speculation, more on the different use cases you have to change around the parameters.
Yes, so how do you deal with the questions of blacklisting? You know, like a lot of ISPs today, they make VPN traffic very difficult or impossible to work. And in general, there is technical blacklisting, like your file transfers are going to be very, very slow for some strange reason, or they are going to be aborted for a strange reason, which nobody understands. But this is simply lack of network neutrality.
Yeah, so the FCC put out some decent net neutrality rules, but we're not sure if they have any teeth to actually enforce them. So in that sense, we're using many technologies through gateway nodes that even if your traffic is blocked or whatnot, you can go through port 80 or some more traditional services to get the data. So I think I'm out of time. Thank you very much for attending. We also will have a booth up, so if you have any more questions, just come find me in the nice blue storage shirt.